Hello, this is Mr. Brooks and welcome to Lesson 6.4, Special Parallelograms. In this lesson, we will learn to use the properties of diagonals of rhombuses and rectangles, and we're going to determine whether a parallelogram is a rhombus or a rectangle. Our first theorem in Lesson 6.9 states each diagonal of a rhombus bisects the two angles of the rhombus. So it's given that the figure is a rhombus, so you know all four sides are congruent. We gotta show that AC bisects angle BAD and angle BCD. Well, if we can get one congruent to 2, then we'll know that AC bisects BAD. If we can get 3 congruent to 4, then we'll know that AC bisects angle BCD. So, how are we going to do this? First, we're going to begin by getting both triangles congruent. AC congruent to itself by reflexive, so the triangles are congruent by SSS. Well, if the triangles are congruent, then we can say that angle 1 is congruent to angle 2 by CPCTC. So we can say AC bisects angle BAD by definition of an angle bisector. And if the triangles are congruent, then we can say angle 3 is congruent to angle 4 by CPCTC. And if 3 is congruent to 4, then AC bisects angle BCD by definition of an angle bisector also. And then we would use the exact same argument for diagonal BD. With that, we would get that to bisect. We get that to bisect angle ABC and angle ADC as well by getting those other two triangles congruent. Our next theorem states that the diagonals of a rhombus are perpendicular. To prove this, let's look at the two green triangles. Well, we know it's a rhombus, so all four sides are congruent. So these two, AB is congruent to AD. We know that BE, we'll call this point right in the middle E, BE congruent to DE because the diagonals of a parallelogram bisect each other, and then AE is congruent to itself by reflexive. So these two triangles are congruent by SSS. Now we know that these two angles have to add up to 180 by the angle addition postulate, and those two angles also have to be congruent by CPCTC. So if the two angles are congruent and add up to 180, then they both have to be 90s. So we have shown that those are right angles. And then you could do it for the other two triangles as well, getting the diagonals to be perpendicular. In example 1, we're asked to find the measure of the numbered angles. Well, right away, we know the measure of angle Q to be 120 also, because opposite angles of a parallelogram are congruent, and it tells us this figure is a rhombus, therefore it's a parallelogram. Well, if it's a rhombus, all four pair of sides are congruent. So we know the top and the bottom triangles both have to be isosceles triangles. And since they're isosceles triangles, base angles of a isosceles triangle are congruent. So 1 and 3 have to be equal to each other, just like 2 and 4 do. And they have to be equal to each other, and they have to add up to 60. So they are all 30-degree angles. In quick check number 1, they're asking us to find, again, the measures of the number of angles. We've got to find the measure of angles 1, 2, 3, and 4. Well, right away, hopefully you look at measure of angle 1 and know that that is 90 degrees because the diagonals of a rhombus are perpendicular. Measure of angle 2, since it's a rhombus, it's a parallelogram, and if parallel lines and alternate interior angles are congruent, so the measure of angle 2 is going to be 50. Well, if angle 1 is 90, then this angle's got to be 90. Again, the diagonals of rhombus are perpendicular. So angle 4, we can then get to be 40. Angle 3, if it's a rhombus, these two sides are congruent. Therefore, this triangle has to be a giant isosceles triangle. And the vertex angles up here and base angles are congruent. So if the given angle is 50, then the measure of angle 3 must be 50 as well. Our next theorem states the diagonals of a rectangle are congruent. Well, this figure is given to be a rectangle. We got to prove that AC is congruent to BD. To prove these two triangles to prove the diagonals to be congruent, I'm going to try to prove these two triangles are congruent. Alright, triangle ABC and triangle DCB. If I can get those two triangles congruent, then I can say AC is congruent to BD by CPC-TC. Well, if it's a rectangle, we know it's a parallelogram, and both pair of opposite sides are congruent in a parallelogram. We know BC congruent to itself by reflexive property. And by definition of a rectangle, we know it's got 4 right angles. So those are both right angles, and all right angles are congruent. So these two triangles are congruent by SAS. And since they're congruent by SAS, then AC has got to be congruent to BD by CPC-TC. We have just proven the diagonals of a rectangle are congruent. In example 2, they're asking us to find the length of diagonal FD. Well, we just said diagonals of a rectangle are congruent. So you're going to set 2y plus 4 equal to 6y minus 5. To solve that, hopefully you would subtract 2y from both sides, giving you 4 equals 4y minus 5. Add 5 to both sides, and you get 9 equals 4y. Divide both sides by 4. So y equals 9/4. Then we're going to plug that bit back in for FD, and let's see, we said 2y plus 4, so it's 2 times 9/4 plus 4. Cross that would be a 2, so 4.5 plus 4, which would be 8.5 for FD. The next 3 theorems are all converses of the 3 we just had. Excuse me. If one diagonal of a parallelogram bisects 2 angles of the parallelogram, then the parallelogram is a rhombus. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. And if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. In example 3, we're asked to figure out if these parallelograms are rhombuses or rectangles. Well, in part A, you have a diagonal bisecting the angles of the parallelogram, therefore A must be a rhombus. In part B, you've got the diagonals are congruent, therefore it must be a rectangle. Quick check number 3 asks us if a parallelogram has angles 30, 150, 30, 150, can we conclude it to be a rhombus or a rectangle? Well, it's obviously not a rectangle because all the angles are not right angles. But does it have to be a rhombus? Well, couldn't I draw a rectangle that looked like this? Excuse me, a parallelogram that looked like this, where this is 30, and this is 30, and this is 150, and this is 150, and obviously it's not a rhombus. The top and the bottom are considerably longer than the left side and the right side. So it does not have to be either one. We will look at example 4 and quick check number 4 together in class. So this concludes lesson 6-4.